This review is going to be talking about how to graph a parabola. Now recall that there's three different equations of quadratic functions. We can have an equation in standard form, we can have an equation in vertex form, and we can also have an equation in factored form. So it's important to know how to graph from those different forms. So first of all, standard form. Standard form looks like this. It's y equals ax squared plus bx plus c. That's standard form. Now, when you're graphing from standard form, most of the time you're going to have a y equals x squared equation. So you're not always going to have a b and a c term. If you don't have one, for example, the standard parabola y equals x squared just looks like that. If you have a y equals x squared parabola where there's no b and there's no c, b equals 0 and c equals 0, those equations all have a vertex at the origin. So the first thing you're ever going to plot when you graph a parabola is you're going to plot the vertex. So for this standard parabola of y equals x squared, it's got a vertex of 0, 0. If I gave you the equation y equals negative x squared, it has the same vertex of 0, 0, just this parabola opens down, whereas the other one opens up because it's a positive a value. A is the coefficient of x squared. So to put this parabola on a graph, we start with the vertex always, which in this case was 0, 0. The next thing we have to do is we have to figure out the step pattern. So the standard step pattern is 1, 3, 5. It follows all of the odd numbers. So 1, 3, 5. And we take those numbers and we multiply them by whatever the a value is. So 1a, 3a, 5a. So if there were a 2 in front of the x squared right here, it would be 1, 3, 5 times 2. So it would be 2, 6, and 10. We'd be doubling the steps. If there were a 3 in front of the x squared, we'd be tripling these steps. So the steps will be determined by what the a value is in your equation. If it's a negative number, it opens down. If it's a positive number, it opens up. Any y equals x squared equation will start at 0, 0. It'll have an origin, a vertex at the origin. So for this case, we're going to graph y equals x squared. This is the standard parabola, and it's going to be put on the graph starting at 0, 0, and then we're going to plot our steps. Now these steps 1, 3, and 5 are all your up or down steps. Your step pattern always goes over by 1 each time. So you start at the vertex and you go over by 1, and then you go up by whatever the steps are. So over 1, up 1, over 1, up 3, over 1, up 5. That's the extremity of our graph, so we're going to stop plotting there. You plot one side of points using the step pattern always going over by 1 and going up or down by whatever 1, 3, 5 times the a value gives you. Now the middle of the parabola is your axis of symmetry. In this case, it happens to be the y-axis because this parabola has a vertex of 0, 0. The equation of the axis of symmetry is x equals 0. So once you draw your axis of symmetry, then you're able to use symmetry to plot the rest of the points on the left-hand side of the axis. So we copy them over. This point right here, the first one, is 1 unit away from the axis of symmetry. So we go 1 more unit over and we can plot its symmetrical point. So I copy the points on the other side of the axis of symmetry to create the symmetry in my parabola. Then I connect the dots to form a nice curve, which takes a little bit of getting used to, especially on the iPad. I use arrows on the left and the right of my parabola, and I label it with its equation. Very important to write the equation up next to the parabola. Often I'll also ask you to label the vertex, which in this case was 0, 0. The y equals negative x squared parabola would be the exact same thing, but it would open downwards. So it would be over 1, down 1, over 1, down 3, over 1, down 5, and it would follow that curve just like that on both sides of the axis of symmetry. Let's look at a different equation that has a different a value. Let's go y equals negative 2x squared. This is still a y equals x squared parabola. It still has a vertex of 0, 0, because remember we said that when b and c are equal to 0, the parabola has a vertex at the origin. So the negative tells us the parabola opens down, and the 2 tells us it's stretched vertically by a factor of 2. That gives us our step pattern. 1, 3, and 5 get multiplied by 2. They get doubled because the a value is 2. So our first step is going to be over 1 down 2, and then over 1 down 6, and then over 1 down 10. We're still going to start off at 0, 0, which is right here on the graph, but we're going to go over 1 down 2, over 1 down 6. Now that is probably all we can fit on the graph because 10 would be way down past where our graph ends. Our axis of symmetry is still the same, x equals 0. It's already drawn here on the graph. That would have been our next step if it wasn't on the same graph already. And then we'd plot the symmetrical points. So copy them over the axis of symmetry to create your other points on the right-hand side. Then you draw your smooth curve. When you're drawing your curve, be careful to note where the next point would be. If I was going to go over 1 down 10, it would be way down at the end of my screen. So that's where I'm aiming for when I draw my curve. Don't stop at this point and draw the curve out this way. It can't go over a full grid mark, a full unit on the graph because I haven't gone down 10. So aim for where the next point would be, even if it's off of your graph. This equation would be y equals negative 2x squared. And notice it's a little thinner than y equals x squared because it's stretched vertically by the factor of 2. Now what happens if I have a number at the end of my equation? Let's discuss when we have a y equals x squared equation with a number at the end. For example, y equals 3x squared minus 4. This equation looks like it's in standard form, but it could also be written in vertex form with a 0 in brackets. It's the same thing as saying y equals 3 bracket x plus 0 squared minus 4. It has a vertex of 0, negative 4. This is the same as your y equals x squared parabola, but it's translated 4 units down, and it's stretched vertically by a factor of 3. So however you'd like to write it, it doesn't really matter, but note that the vertex is 0, negative 4. So that's the first thing we put on our graph. We write our vertex right on there. We draw 0, negative 4, 0, negative 4. This parabola is going to open up. I know that because the a value is positive. And the steps are going to be 1, 3, and 5 times the a value of 3. We're tripling our steps. So we're multiplying them by 3 each time. So our steps are going to be 3, 9, 15, etc. So from the vertex, we're going to go over 1, always over by 1, and we're going to go up by 3. So over 1, up by 3, that's our first dot. Over 1 more, up by 9. So over 1 more, up by 3, 4, 5, 6, 7, 8, 9, right over there. And our 15 doesn't fit on the graph. So our axis of symmetry again is going through the vertex. It's a vertical line. It still in this case is the y-axis. So x equals 0 is the equation. And we use it to copy our points over to the left-hand side. So this point has a symmetrical point over there, and the second point is 2 units away from the axis of symmetry as well. Then we trace a nice smooth curve. We remember to not go up past the next grid line because 15 is really far to go. There we are, and the equation y equals 3x squared minus 4 goes next to the parabola. So let's discuss an equation where the vertex is not on the y-axis. So if we had an equation y equals negative 2x plus 3 squared plus 4. That's an equation in vertex form. And that equation in vertex form is going to be starting our parabola at the vertex hk. Remember to change the sign of the 3, so negative 3, positive 4. That's where we're going to start on the graph. So we're going to plot that point right here at negative 3, positive 4 on the graph. Negative 3, 4, and we label it. That's the vertex. Next we're going to say, okay, which direction is this parabola going to go? Is it going to open up or open down? This negative sign tells me it opens down, and the 2 tells me I have a step pattern that's not 1, 3, 5, but it's a doubled step pattern. We're multiplying them by 2. So my steps are going to be 2, 6, 10 from the vertex, always going over by 1. So we start at vertex negative 3, 4, and we go over by 1, down by 2. From that spot, we go over by 1 more, down by 6. 1, 2, 3, 4, 5, 6. Then over by 1 more, down by 10. Now the 10 would go off the graph. So when I finish my problem, I'm going to aim for somewhere right at the bottom of the screen. Next up is the axis of symmetry. Remember, the axis of symmetry corresponds to the x-coordinate of the vertex. X equals negative 3 is the axis of symmetry. So I'm going to draw that on my graph. Through negative 3, I'm going to put a vertical line, and I'm going to label it with its equation, x equals negative 3. That axis of symmetry is going to allow me to plot my symmetrical points to the other side of the axis. So this first point that I drew is 1 unit away from this axis of symmetry. So I go 1 more unit away on the left-hand side, and that's where my next point belongs. So I'm going to copy that point over using the symmetry. The following point is 2 units away, so 2 more units away, and I can copy that point. And I'm going to aim for the bottom of the screen for 1 more unit over and make sure my arrows are placed appropriately. If I wanted to check where my y-intercept would be in this graph, if I wanted to verify where it would cross the y-axis way down there, from vertex form, the only way I could do that would be to substitute in x equals 0. So y equals negative 2 times 0 plus 3 squared plus 4. And following BEDMAS, I know that it's negative 2 times 9 plus 4, which is negative 18 plus 4. So negative 14 would be the y-intercept. So I can picture where it would be on my graph. If I had to graph this and I was asked to plot the y-intercept, I would use that method to solve for the y-intercept in vertex form. The symmetrical point would be double the axis of symmetry for the x-coordinate and the same y value as the y-intercept. So let's look at a different example. Y equals 3 x minus 1 squared plus 2. First thing you ever do when you're graphing a parabola is you plot the vertex. So this parabola has a vertex of positive 1, positive 2. Remember to change the sign from the brackets to your vertex. So the vertex is 1, 2. So I plot that on my graph. 1, 2 is right there. Once I plot the vertex, I'm able to also draw my axis of symmetry. So it goes right through the vertex. It's a vertical line, and its equation is x equals whatever the x-coordinate of my vertex is. So in this case, is x equals 1 is the axis of symmetry. And it's this one right there. So I'm going to use my a value to plot my points in the graph. I'm going to look at my a value and say, okay, it's a 3. The positive means it opens up, and the 3 means the step pattern is going to be triple. So steps are tripled. So instead of 1, 3, 5, I'm going to multiply those by 3 to get my steps. So I'm going to have 3, 9, 15. So I'm going to start at the vertex. I know I'm opening it up, so I'm going to go over 1 and I'm going to go up by my steps. Over 1 and up 3. 1, 2, 3. Over 1, up 9. Well, that's even off my graph. So it looks like I can only have those two points plotted on that side of the parabola. I'm going to aim for one way up here. That's probably where the 9 is. It's right at the top of my screen. So then I'm going to use the symmetry of the axis of symmetry to plot my points on the other side. So over 1, up 3 is also 1 unit away from the axis of symmetry. And I'm going to aim for the very top of my screen over here as well. My graph is going to only have a few points on it, and that's okay. Sometimes you might not have as many steps as you're able to in other parabolas. You have a symmetrical axis of symmetry that's drawn in there, and you have arrows. You're labeling it with its equation, y equals 3x minus 1 squared plus 2. You have a y-intercept, which happens to be one of the steps, and that's okay. This y-intercept here is 0, 5. If you're not sure if you plotted it correctly, you can easily substitute 0 in for the x value. If I put a 0 right here, negative 1 squared is positive 1 times 3 is just 3 plus 2 gives us the 5 that we have drawn on our graph. Our symmetrical point has double the axis of symmetry. So the axis of symmetry was a 1, x equals 1. So you double it and it's 2. And it has the same y coordinate as the y-intercept. So 2, 5 is my symmetrical point. Sometimes we might give you graphs and we might ask you to graph from factored form. So let's give an example in factored form just to be sure we all understand how to do that. Y equals negative 2 x plus 1 x minus 3. Now, the first thing you should draw on the graph in vertex form is the vertex, because that's what the vertex tells you. So let's look at factored form. What does factored form tell us? It tells us the roots. So that's the first thing we should draw on our graph from factored form. The roots are going to be the same numbers as the numbers in the brackets, but they're going to have opposite signs. So the roots are going to be negative 1 and positive 3. So we're going to plot those on our graph. Negative 1's right here, and positive 3 is right over here. We're going to give their coordinates, so 3, 0, negative 1, 0 as well, negative 1, 0, and those are our two roots. Now we know the parabola is supposed to open down because it's got a negative a value. We know it's stretched vertically by a factor of 2, so our steps are going to not be 1, 3, 5, but they're going to be double of that. Times 2 gives us 2, 6, 10. But we need to find out where the vertex is going to be in order to plot our step pattern. So how do we find the vertex if we know the roots? Well, if we know the roots, our vertex is going to have an x coordinate that is the average of those roots. So for the vertex, the x coordinate is going to be, or the axis of symmetry, same thing, is going to be the two roots added together and divided by 2. So 2 over 2 is 1. That's the axis of symmetry, and it's also the x coordinate of the vertex. We can use that to plot our axis of symmetry right away. So there it is. Its equation is x equals 1. It should be right in the middle of our two roots, and we see that it is. Now, if our parabola opens down according to our equation right here, we would expect our vertex to be above the roots, somewhere up on this line, so that it can open down and pass by those two x-intercepts. So we're going to hope that when we substitute x equals 1 into the equation, we get a vertex that is a positive number above the x-axis. So let's do that. Let's take x equals 1 and let's substitute it into our equation. Our equation was y equals negative 2 bracket x plus 1 x minus 3. So we're going to sub in x equals 1, which is our axis of symmetry. So y equals negative 2 times 1 plus 1 times 1 minus 3. We substitute that x value from the axis of symmetry into the x parts of our equation. Then we're going to use BEDMAS to simplify. So brackets first. Then we multiply. Negative 2 times positive 2 times the other negative 2 is a positive 8. So our vertex then is going to be 1, 8. That makes sense with what we see on our graph. So let's go back up and let's draw that vertex right on there. 1, 8 is up 8, right up there. 1, 8. That's where our vertex lies on our graph. So our step pattern is 2, 6, 10. It's opening down, so we're going to go over 1, down 2, over 1, down 6. Oh, we met our roots, so we know we did it properly. Over 1, down 10. And then we're done. Other side of the parabola, cross over the symmetry shows us that these 2 points are lined up. Down 2, down 6, and down 10. So we're going to plot these points. We're going to draw a nice smooth curve. we see that the y-intercept of this graph is 1, 2, 3, 4, 5, 6, 0, 6. That's what we would get if we plugged in an x value of 0 right here where the x's were in our equation and solve for the y value. Our symmetrical point is the one that is across from the y-intercept. You notice it's twice the axis of symmetry, so you double that 1, you get a 2. That's the x value. Right here is a 2. And it has the same y-coordinate as the y-intercept. So 2, 6 would be our symmetrical point to the y-intercept. So that's how you graph from both standard form, which kind of is the same thing as vertex form with some zeros plugged in there, and from factored form. Remember, to find the axis of symmetry from factored form, you average the roots, and to find the y-coordinate of the vertex, you just substitute the x value from the axis of symmetry into your equation, and you solve for the y. In any equation, if you want to find the y-intercept, you can plug in the x equal to 0 and solve that way.